All right. 5, 3. The complex plane of de Moivre's theorem. All right. Complex plane. It's a two-dimensional plane. Every point on it is of the form A plus I times B. It's over A and up B. So here's 0, here's 1, here's -1. So this horizontal line is the x-axis, is the real axis. This here is the imaginary axis, and 1 plus I is over 1 and up I. The complex numbers have an arithmetic. You can add, subtract, multiply, and divide. You add them by combining like terms. A plus IB plus C times C plus ID. You add the real parts, A plus C. And you add the imaginary parts, I times B plus C plus D. Multiplication, you treat the numbers like ordinary numbers, specifically first out or inner last distribution. And however, you add an I squared equals -1. This is the trick that makes it a complex number. So A plus ID times C plus ID after you expand, and IB times ID is -BD. So you get real part AC minus BD and imaginary part AD plus BC. And well, okay, we can apply the same rectangular and polar form trick to the complex numbers as you can to points in the plane. A number of the form A plus IB, that's its rectangular form, can be plotted by R and theta by noting that A is R cosine theta and B is R sine theta. You plot these into here, and Z is R cosine theta plus I times R sine theta. Now these have a common factor of R which pulls out. You get R times cos theta plus I sine theta. This is nice because the R and the theta are now in separate parts, separate from each other. R is a radius, root A squared plus B squared. Theta is the angle from the positive real axis. Now, this thing here, cos theta plus I sine theta, we give it a name, CIS, cis theta, cosine plus I sine. Now, if you graph cis theta, it's on the unit circle. It's 1 unit out from the origin. And it's an angle theta from the positive real axis. So there it is. So R cis theta is the R cis theta. It's out of distance R at an angle theta. Now the advantage of this polar form of the complex numbers is that it makes multiplication really quite easy, because look what happens when we multiply cis alpha times cis beta. Cos alpha plus I sine alpha, cos beta plus I sine beta. After you multiply and I squared equals -1 and so on and so forth, you get this. Cos theta, cos alpha, cos beta minus sine alpha, sine beta, that's the real part, plus I times sine alpha, cos beta plus cos alpha, sine beta. That's the imaginary part. Hold on a second, that needs that's a lot for a 3 page. Sorry, page 3. Need to put another parenthesis here. Okay. Now this cosine minus sine sine is cosine of a sum, cosine of alpha plus beta. Sine cosine plus cosine sine is a sine of a sum. These are the angle addition formulas. Here we go. Cosine alpha plus beta plus I sine alpha plus beta. That's cis cosine plus I sine of alpha plus beta. So cis alpha times cis beta is cis of alpha plus beta. When you multiply two complex numbers, you add their respective angles from the x-axis. Now, multiplying cis's is cis of a sum. By similar reasoning, it follows that the dividing cis's is cis of the difference, and because it's the opposite of adding. Dividing is the opposite of multiplying, and subtracting is the opposite of adding. And cis alpha to the n is cis of n alpha, because an nth power is n multiplications, whereas n times alpha is n additions. So if you have two complex numbers and you multiply them, divide them, or take a power, their product, well, if you work it out, it would be RS cis of alpha plus beta. So you multiply the lengths and add the angles. R cis alpha divided by S cis beta, you divide the lengths, R over S. Cis of alpha minus beta, you subtract the angles. And cis alpha, R cis alpha to the nth is R to the nth cis of n alpha. You take up, you power the length and multiply the angle. So here's how it looks. If here's r cis alpha and here's s cis beta, here's a length r and a length s, an angle alpha and an angle beta, then their product ZW is rs cis of alpha plus beta. You multiply the lengths and you add angles. Now, complex roots, that's a bit of a trouble. Partly because there's actually going to be more than one root for a given power. So if we want to solve w to the n equals r cis alpha, so we want to find what is w. Well, we'll call it s cis beta, and we'll want to find what s and beta are. So s cis beta to the nth is r cis alpha. This s cis beta is nth power is s to the n times cis of n beta. You take a power of s, and you take a multiple of beta. S to the n cis n beta equals r cis alpha. Now, I didn't mention it, but two complex numbers are equal if their lengths are equal and their angles differ by an integer multiple of a rotation. Because if you go around once or twice or n times, you wind up at the same place. So s to the n is r, and n beta equals alpha plus an integer multiple of rotations. All right, if s to the n is r, then s is the nth root of r. N beta is alpha plus 2 pi k for k some whole number. Then if you divide, beta is alpha plus 2 pi k over n. So here are the nth roots of r cis beta, r cis alpha. Nth root of r cis of the quantity alpha plus 2 pi k over n. K goes 0, 1, 2, 3, 4 up to n minus 1. So they're even. So these roots are all evenly spaced around the circle with radius nth root of r. For example, so let's do some examples. 4 minus 4i, what polar form for that? Well, let's graph it. It's over 4 and down 4. R, the radius from the origin, is root of 4 squared plus negative 4 squared, which comes up to 4 root 2. And since these sides are equal, this is an isosceles right triangle, and the angle is negative 45 degrees, negative because it's clockwise. So 4 minus 4i is 4 root 2 cis of negative 45 degrees. 2 cis 120. Okay, well, if it's 120 here, and we'll turn it to rectangular form. So 120 here means that this supplementary angle is 60. So we have a 30, 60, 90 triangle. Radius diagonal is 2. The near side is a half. The far side is root 3 over 2. So this is negative a half here and positive root 3 over 2. So it would be 2, which is r, times the cis 120 is negative a half plus I root 3 over 2. Multiplying throughout by 2, you get negative 1 plus I root 3, and that is 2 cis 120. Here we have two complex numbers, 2 cis 40 and 4 cis 20. Ask for what's their product, what's their ratio, keep it in polar form. ZW, you multiply the lengths, 2 times 4. Cis of, you add the angles, 40 plus 20, and you get 8 cis 60 degrees. Now I could expand it into rectangular form. Let's leave that for now. Z over W, the length is 2 divided by 4. Cis of the angle is 40 minus 20. So you get 1/2 cis 20. This, I don't know a particular form for this, so we'll keep it in polar form. Here we have 2 plus 2i, root 3 minus I. What's their product? What's their ratio? And in polar form. I mean, you could find their products and ratios in rectangular form by the usual complex arithmetic, but this will do as is. Z is over 2 and up 2. So this is a 45-degree angle. The diagonal is 2 root 2. 2 root 2 says 45 degrees. Okay, so root 3 minus I is over root 3 minus I. It's easy to check that this length is 2, and this is a 30, 60, 90 triangle. I give it a negative 30 degrees because it's clockwise. So W is 2 cis of negative 30 degrees. Their product, you multiply the lengths, so you get 4 root 2 cis of, add the angles, 15 degrees. 4 root 2 cis 15 degrees. Take the ratio. Well, the ratio of the lengths, 2 root 2 over 2 is root 2. 45 minus negative 30 is 45 plus 30, which is 75 degrees. So Z over W equals root 2 cis 75 degrees. Here we have a third power of 4 cis 40 degrees. And put that in rectangular form. What is it? Well, third power of 4 cis of 3 times 40 degrees. 4 to the third power, 64. 3 times 40 is 120 degrees. And so, okay, this is, as we saw before, is a 120-degree angle with a 60-degree supplementary angle. And after a little bit of trigonometry, that's cis 120 is minus a half plus I root 3 over 2. That times 64, the 4's cancel, the 2's cancel, and we're left with minus 32 plus I times 32 root 3. Oh, by the way, you notice I put the I in front of the roots. That's to avoid the possibility of I somehow being winding up looking like it's inside the root. And I do take points off of that. I think it's just simply more clear to put the I in front of the imaginary part. Also because, in my opinion, I is less like a number than it is like a sign like plus or minus. It's the sideways sign. Okay, here we have root 5 cis 3 pi over 16 to the 4th power. Okay, root 5 to the 4th, cis of 4 times 3 pi over 16. All right, root 5 to the 4th, that's 5 to the 4 halves. 4 times 3 pi over 4 is 3/4 pi. 5 to the 4 halves is 5 squared root 25. 25 cis of 3 pi over 4. All right, cosine is negative root 2 over 2. Sine is root 2 over 2. So minus root 2 over 2 plus I root 2 over 2 times 25. Multiply the 25 throughout, and here's the rectangular form. Minus 25 root 2 over 2 plus I times 25 root 2 over 2. Here we have the 5th power of 1 minus I. Well, 1 minus I is over 1, down 1, diagonal root 2, angle is negative 45 degrees. So we have root 2 cis negative 45 degrees, that to the 5th power. Distribute the 5th power, root 2 to the 5th, cis of 5 times negative 45 degrees. So okay, root 2 is a half power, to a 5th power is a 5 halves power. 2 to the 5 halves power, cis of, this works out to negative 225 degrees. Let's add 360 degrees to turn this into a positive 135 degrees, which is just short of, which is in the 2nd quadrant. And if you work out the trig, that's going to be minus root 2 over 2 plus I root 2 over 2. 2 to the 5 halves is 2 to the 2nd times 2 to the half. Therefore, 4 root 2 times minus root 2 over 2 plus I times root 2 over 2. Next and last step is distribute the 4 root 2 throughout. And after a little bit of that, you get minus 4 plus I times 4. That's the 5th power of 1 minus I. Now here we're going to have finding a 4th root, all 4th roots of 4 minus I times 4 root 3. All right, now 4 minus I 4 root 3 is over 4 and down minus 4 root 3. This is in fact a 30, 60, 90 triangle. Its radius is 8, and this is negative 60 degrees. So W to the 4th equals 8 cis of negative 60 degrees. So we solve this by, okay, it'll be 8 to the 1/4 power, cis of 1/4 of negative 60 plus 360k degrees. Okay, these are the full rotations, and we take take 1/4 of those rotations. So end result, 2 to the 3/4, cis of negative 15 plus 90k degrees. Because 360 over 4 is 90. So you have a circle with radius 2 root 3 over 2 times root 3 over 4. I should have that in. And the angle, well, negative 15 degrees will do. Then add 90, you get 75 degrees. And add 90, you get 165 degrees. And add 90, you get 255 degrees. This here has these 4 4th roots evenly spaced around the circle. Here we seek the complex 5th roots of I. W to the 5th equals I. Well, I is 1 cis 90 degrees. So fifth root will be fifth root of 1 times cis of 90 plus 360k degrees over 5. All right, so 1 cis, and this works out to be 18 plus 72k degrees. So 18, or that plus 90 is cis 90. Another 72 gives you cis 170, 162. Another 72 degrees gives you cis 234. Another 72 degrees gets 306. There you go. 18 degrees, 90, 162 degrees, 234 degrees, 306 degrees. All spaced evenly as a regular pentagon on the unit circle. And that generally happens with these nth roots. They're spaced evenly around a circle. Well, that should do that. Now let's call